What will happen if we will see the hidden structure inside our own bodies? Imagine opening your lungs and suddenly you see a giant tree inside your chest. Branches that keep branching, getting smaller and smaller, thinner than a human hair. Thousands of those branches, each ending in tiny air sacs called alveoli. The total? Around 300 million, some say up to 600 million. If you stretch out the entire surface area, it will be as large as a tennis court. And all of that fits inside our narrow chest. Crazy, right? But wait, why do our lungs have to look like a tree? And why does the same pattern appear everywhere in nature? In sharply branching lightning, in winding rivers, in leaves, even in that weird-looking Romanesco broccoli? What if there's a simple rule that makes everything look complicated but is actually very orderly?
I found traces, very strong traces, I must say, of order in that roughness.
This is a mathematician named Benoit Mandelbrot discovered. He looked at messy shapes in nature, coastline that get more detailed the closer you look, clouds that can't be shaped into boxes, round mountain, and he said, this isn't chaos, this is fractal. In this video, I'm going to explain what fractals are, and how this mathematical pattern will make you even more amazed at how this universe is designed. Even thanks to Mandelbrot mathematical pattern, doctors have been able to detect lung disease.
Surprisingly enough, has been of great help to the surgeons studying lung illnesses.
So watch until the end so you don't misunderstand.
This is the Mandelbrot Set. It's been called the thumbprint of God.
So what's a fractal? A pattern that repeats itself, no matter how many times you zoom in. You zoom in, the large pattern appears again inside it. Zoom in again, still the same. No end. Self-similarity. Infinite complexity from super simple rules. We usually admire mathematics for its perfect shape. Circles with pi, the golden ratio that makes flowers and shells look beautiful, the Pythagorean theorem that GPS still uses today. Those shapes are neat, clean, ideal. But nature? Nature doesn't care about those ideals. A mountain isn't a pyramid. A cloud isn't a perfect sphere. Are they less beautiful because they are rough? Or is this another kind of perfection? One that's more efficient, more adaptive? Let's play a small game called the chaos game. Draw 3 points to form a triangle. Choose a random starting point inside it. Roll a die. Pick one of the corner points. Then draw a new point exactly halfway between your current position and that corner. Repeat it over and over. At first, just random dot, no order. But if you repeat it 10 of thousands of times, and boom, the Sierpiński Triangle appears. A big triangle filled with smaller triangles. Inside them even smaller triangles forever. Absurd, right? It looks random, but is controlled by one simple rule. That's a fractal. Just like Romanesco broccoli, cut one floret, and its shape looks exactly like the whole broccoli.
Well, it's very interesting. If you cut with a sharp knife one of the florets of the cauliflower and look at it separately, you think the whole cauliflower, but smaller. And then you cut again, and you still get more cauliflowers.
Trees, leaves, our blood vessels, our lungs, all the same way.
In fact, by complete fluke, I got involved many years ago in the study of this form of complexity, and to my utter amazement, I found traces, very strong traces, I must say, of order in that roughness.
Mandelbrot discovered this using advanced computer at IBM in the 1970s. He played around with a simple formula, z squared plus c in a complex plane. Plug in a number, repeat it over and over. Some values explode to infinity, some stay bounded. Plot the ones that stay bounded. The Mandelbrot set appears, a magical shape that, when you keep zooming in, reveals miniature copies of itself. Beautiful spirals, unexpected pattern, all from stupidly simple equation.
This shape is of an extraordinary complication. The equation is written there. Z goes into z squared plus c. It's so simple, so dry, it's so uninteresting.
It's absurd, but it's true. What looks incredibly complex in nature is often born from the repetition of the simplest rule.
When we look at complexities in nature, we tend to ask, where did they come from? There is something in our heads that says complexity does not arise out of simplicity. It must arise from something complicated. We conserve complexity. But what the mathematics in this whole area is telling us is that very simple rules naturally give rise to very complex objects.
So this universe isn't random chaos, there's design behind it. Fractals allow our lungs to exchange as much oxygen as possible in a small space. They allow leaves to distribute water throughout their structure. They allow rivers to flow efficiently, blood to reach every cell. Doctors now use fractals to detect lung disease.
Well, surprisingly enough, amazingly enough, the anatomists had a very poor idea of the structure of the lung until very recently. And I think that my mathematics, surprisingly enough, has been of great help to the surgeons studying lung illnesses.
They are also used to model turbulence, stock markets.
Well, actually, I started, oddly enough, studying stock market prices. For 50 years, people were sort of poo-pooing because they could do it much easier. But I tell you, at this point, people listen to me.
In the end, it all comes down to belief. Is this beautiful pattern emerged from simple rules repeated endlessly? Is this universe designed with purpose, not chaos, but deep order? It invites us to ask, if we also follow a few simple principles in life, repeated consistently, could the same beauty and meaning emerge in our life? What if our life also have a beautiful fractal pattern?